Hey guys, and welcome back to the 8th video in my intermediate Python tutorials. In today's video, I'm going to be continuing with the collections module, and we're going to be talking about a data type known as the DEC. So yes, this says DQ right here, and the title of the thing is spelt DQ, but the way that you pronounce it is DEC. And I just found that from reading the documentation. Otherwise, I was going to go through this whole video saying DQ. Anyways, DEC is the proper way to say this word. So if I do end up saying DQ throughout the video, please don't leave an angry comment about it. I don't know why, I just keep saying it. But anyways, DEC is the proper way. So why would we want to use a DEC over a typical list? So pretty much it kind of looks the same as a list, and I'll show you in just a second. But the reason why we'd use a DEC is because it's faster in terms of adding elements to the end and the beginning of a list. So rather than using a list, you want to use a DEC because it's going to be faster. Whereas if you're trying to randomly access elements within a container, so a list, then you're going to want to use a list over a DEC. And if that's confusing, don't worry, I'll kind of show you how we as we go through. So let's start by creating a DEC and see how that works. So I'm just going to say D, and that's going to be stand for our DEC is going to be equal to a DEC. And then this just takes an iterable argument. So in this case, I'm going to type in hello, but I could give it something like a list, a dictionary, so on. So anyways, D equals DEC, hello. Now if I run the program, press F5, and I simply print D to the screen here, you can see that we get DEC and then HELLO. I just split that up into what looks like a list, but it's actually a DEC. Okay, so now let's go through a few methods that we can use on this. So obviously we can use something like append. So we can append an element to the end. So I'm going to append something like 4. I can append another element, do something like 5. And if we run this and then print it again, you can, oops, didn't mean to do that. Then you can see we get hello and then 4, 5, so on. So you can append. A nice thing is you can actually append to the beginning of the list as well. So I can say append left instead of just regular append. And now you can see when we run the program, and we print D. Don't know why that didn't work. Let's see here. We get 5 and then hello 4. So that's a nice method as well. We can do the same thing with popping, which is removing elements from the DEC. So I can do pop in this case, and I'm not going to do 4 in here, so I can do d.pop. And then I can also do d.pop left. And what pop left is going to do is it's simply going to remove the first element in our DEC rather than the last. So pop, this works on lists as well. And dictionaries and stuff, you can remove the last element or whatever index you type in here. So like 5, 2, whatever, that's the one it's going to remove. Pop left simply removes the first one. So I'll do this and then print D, and you can see that we are left with ELL because we removed O and we removed the H. Okay, another method that we can use is clear. This one is simply going to remove everything from the DEC. So that's pretty standard. If I print D again, then you can see that we have an empty DEC now. Okay, the next few that I'm going to talk about here, I believe you can use on some other containers in Python, but they do work on this DEC as well. So let's go through it. So now that we already cleared our DEC, let's just go ahead and add some more things to it. So what we can do is we can do something called extend. And what extend is going to do is it takes an iterable argument, which means anything that's a container, so like a list, a string, something like that. And it's going to put it at the end of our list. So if I have something like 4, 5, 6, and I run the program and I print D, you can see we get 4, 5, 6 at the end of our list. Now to show you what happens if you already have something in, I called it a list, but our DEC, is if I extend again, I'll extend something like, so we can see it better, hello, then what we get is print D, we get 4, 5, 6, and then hello. So this is a way to add multiple things into your DEC. So again, if I make like a list and I go like 1, 2, 3, this is going to work as well. So we should get 4, 5, 6, 1, 2, 3, and print D. And there we go. We get that as well. So if you ever don't want to run through like a for loop to add an entire list into a DEC, then you can simply use extend. Extend also works really nicely with extend left, which is going to add to the beginning of our list. So now we have a list of 4, 5, 6, 1, 2, 3. Let's see what happens if we extend the word hey to the left side of the list. So I'm going to print that, and you can see we get YEH 4, 5, 6, 1, 2, 3. You might say, well, why didn't we just get H? Well, it's because we're actually extending to the left. So we're going to add this in the reverse order. And that should make sense because if you're extending this first, and then you extend this, and then you extend this, y should be the first element on the left side of our deck, like that. Okay, so now we're going to use a few other methods. So this one is probably the most useful one that the deck has, and the reason why you would use it, especially if you're going to be dealing with things at the beginning and the end specifically, and it is known as rotate. So what this does is it takes a integer in here at either positive or negative. If you put a positive integer in here, it's going to rotate all of the elements by that amount to the right. Otherwise, it's going to, if you put a negative element in there, rotate everything to the left. So just see what happens if I put -1 in here to rotate to the left, and then we'll print down here. Sorry, it's at the bottom of the screen right now. And you can see that we went from this one, which was the last D or whatever when I printed it, and now we've rotated everything over. So 3's moved over to the position of 2, and when we get all the way over to here, we've switched E and Y. So E's moved over here, and Y has been rotated back to the end of the list. Now you can actually rotate with other numbers as well, so rotate by 2, and then you can see if I print D down here, that we get it rotated 2 elements over now. And this is really useful when you're trying to solve certain problems to be able to use this rotate. Again, you can do the same thing with positive. So if I just rotate it by 1 now, and I simply print D, you can see that now we've rotated to the right side. So 3, which was originally here, has now been moved up to the beginning of the list. Okay, so now that we've talked about that, there's one last really useful thing that I left out on purpose because I wanted to show now that we can do with these decks. So when we initiate our deck here, we give it an iterable object. We don't have to give it anything. It'll just create a blank one if we do that. But there's something that it has called maxlen. Now, if I do something like maxlen 5, and I'm just going to remove all this, and I'll show you how this works. So I have a maxlen of 5, and I have a string that has 5 characters in it. If I try to add something to my deck here, so I'm going to print it here just so it saves us some time. I'm going to print D, and then I'm going to go d.append, let's do 1, and then print D again. Let's just watch what happens. So you can see we have a maxlen of 5, we start with hello, and then when we add 1, H is actually removed from our deck. Now the reason that happens is because when we set this max length, when we start adding things into the list, it needs to remove something to maintain that attribute of a maximum length of 5. So it removes the first element from our deck. And that's really useful as well if you're solving problems, because then you don't have to deal with removing things every time you add something to the end, or removing like a slice of, for example, a list if you're going to be adding more than one thing. So if I extend like something like, let's see here, 1, 2, 3, now we should see that H, E, and L should all be removed, and we should have L, O, 1, 2, 3. So let's try it. And there we go. We get hello, and we get L, O, 1, 2, 3. And we didn't have to deal with figuring out how many elements we need to take from the left side, from the right side, because of this maxlen. Now, just to note, you can't change this maxlen by doing something like d.maxlen equals 5. It's, or I guess we'll do like 6 because it's already 5. You can only access what the maxlen is by just doing simply this, print d.maxlen, and this should just give us 5, and it does. But if I try to do what I was showing you there, so d.maxlen equals 5, you'll see the error that comes up. And it says this attribute of maxlen is not writable, so we can't actually change it after we've initiated that value. So anyways, that's pretty much been it for deck within collections. This is really useful, and you might not see a use for it now, but if you start solving some more advanced problems, using this deck will make your life a lot easier with those methods that I went through. And I'm going to copy all of them down into like a little paste bin thing, so you can click the link in the description there if you want to see all of them in a list, so you don't have to specifically memorize that. Other than that, you can always just go to the documentation and have a look. If you just search up like DQ collections Python, it goes through what all of these do. Again, I forgot to talk about reverse, but it's pretty straightforward. You can use reverse, and if you're followed up to here, you probably already know that one. So anyways, that's been it for this video. If you guys enjoyed the video, please make sure you leave a like and subscribe, and I will see you again in the next one.